All right, hello. Today we're doing another subset sum problem. Um, what, huh? We're doing another DP problem. It's called subset sum. Yes, there we go. And the problem is given a set of positive numbers, determine if a subset exists whose sum is equal to a given number s. Example 1, you have 1, 2, 3, 7, and then we want to see if we can create the sum of 6. It's true because we can create um, a subset in which we can create the sum, which is 1, 2, and 3, right? So we want to be able to see if we can solve this problem, so we will get into it. We're going to be creating a variable called n for the length of num because it helps, we don't have to keep calling length of num every single time we want to use it. We can just call it, I guess. We're going to be doing bottom-up programming again. So we're going to do false for, I'm going to actually use C this time because it shows how many columns we have. False for C in range of sum plus 1. Sum plus 1. And then here we're going to do for R in range of N. So this will make enough columns for 0 through the sum that we're trying to find. And then we're going to have one row for every number in our, what is this? Num. You know what? I'm going to do nums because I don't like, actually it doesn't really even matter because we have the variable anyways. It's just that one. So yeah, we create this 2D array. And now we have to, I guess essentially code out the base cases. So for I in range of n, we're going to do dp. Why does that look so indented? Oh, dp I of 0 is equal to true because we can always create a sum of 0, which because it's 0. And then for, okay, actually I'm going to do nums. For number in range of I to sum plus 1, we're going to, did I say I? 1? We're going to check, we're going to set the one value where dp of 0 of the number, is equal to true if the nums array sub 0, which is the first number, if it is equal to if the number, else false. So basically, if we're able to find our first number within our array, then we can set that to true because because with one number, that's the only sum you can create, right? Actually, I'll write it down. So this is a base case. We can always make a sum of 0, right? For a one number subset, we can we can only create a sum of that number, right? So that's how our base cases are coded out. This is essentially a base case as well for the one number, but I guess I just don't want to label it. So now we got to process everything else, right? So for I in range of 1 to n, we don't need to do all of n anymore because we handled the first number here. We're going to do for j in range of 1 to sum plus 1. Whoops. Sum plus 1. We now need to calculate whether or not we can find the number, or like find our current number as a sum, right? So if dp of I minus 1 j, if the value right above is true, so which means with the smaller subset of numbers we can create the sum, then we can just automatically assign it because if we can create it with a smaller subset, then we can obviously create it with a bigger subset as well. And the else if j is greater than or equal to nums I, then we can do the whole subtraction thing, right? So we can do dpi j is equal to dpi minus 1, and then j minus nums I. There we go. So basically, this will check. So if we get rid of the current number that we are at, and then we go to the row above, so for the smaller subset, and for the smaller number, without including, like, so for a smaller sum, because we take out the number that we're currently looking at, and if we can create that with a smaller subset, then we can add our current number to that, and then we can create the number that we're currently looking at, right? So this would make it true. And then at the very end, we just want to return dp I minus 1 and, well, not I minus 1, n minus 1 and the sum. So let's look at what numbers we are expecting, or like, no, true or false values. So we're expecting true here. We can kind of see that from up here. 10, we can create it because 1, 2, 7 creates 10. And here 6, we can create 4, and that would create 8. 4 and 1 create 5, and that's the closest we can get. 4 and 3 create 7. So we needed a 4 and 2, or 3 and 3, 1, 5 maybe. But yeah, so since we can't create any of those, this is actually false. So with that being said, let's run the code. And we in fact do get true, true, false. So yeah, today's, it was slightly easier. Well, at least I believe it's slightly easier. I also, after doing the 2 problems that we already did, this is easier for me, I guess. So yeah, with that being said, that's all for today's video. Oh, and another thing, so I'm also doing like practice interview questions right now from the Grind 75 list, from the Tech Interview Handbook. I'll link my stream down below. I guess this is going to be a little bit late because I think my videos are scheduled for the day after. But I still should be doing practice interview problems. So you can catch me on my stream like later on at night. On the weekends, maybe earlier. We'll see. And yeah, I'm just doing practice interview problems on stream. You can ask me questions live, I suppose. And we can end it there, I guess. Yeah. So with that being said, that's it. Thank you for watching, and see you next time.